Now, matrices inherit many properties possessed by real numbers. Let matrix A be the entry Aij. It's going to be any n by n matrix. The n by n matrix O, which is the zero matrix because it's consisting entirely of zeros, that's going to be your additive identity. So the n by n matrix B is going to be the additive inverses of these, which gives us our zero matrix. So we can also write B is equal to negative A on here. So when we do this, we take matrix A minus matrix B and do all sorts of mathematics behind it. That means matrix A minus matrix B is the same thing as matrix A plus the opposite of matrix B. So we could have used that on the previous example too. Let's get into this exploration here, computing with matrices. Now, let's talk about matrix A and matrix B. They're going to be 2 by 2 matrices with Aij equal to 3i minus j, and matrix B be I squared plus j squared minus 3, for I is equal to 1, 2, and j is equal to 1 and 2. So matrix A will be, for your first part, we're going to let I equal 1 and j equal 1. So when we put it into the first one there, so 3 by 1 minus 1, which is 2. So there's our first entry 2 of our 2 by 2 matrix. Now for our second entry, our first row, let I equal 1, j equal 2. This means first row, second column. So 3 by 1 minus 2, which will be 1. So there we have that there. Now, second row, first column, 3 by 2 minus 1 is 5. Then our second row, second column, this will be 4. So there is matrix A. Now for matrix B, we're going to use I squared plus j squared minus 3. So I will equal 1, j will equal 1. So I squared plus j squared minus 3. 1 plus 1 is 2, minus 3 is negative 1. So first row, second column, 1 squared plus 2 squared minus 3. 1 squared is 1, 2 squared is 4, so that gives us 5. Minus 3 is 2. Moving down to our second row, first column, we're going to have 2 squared plus 1 squared minus 3. Again, pretty much the same thing as before. That'll also give us 2. And then second row, second column, 2 squared plus 2 squared minus 3. It'll be 4 plus 4 is 8, minus 3 is 5. So our matrix will go negative 1, 2 going across, and then 2, 5 going across. So there's our matrix. Now number 2, it says determine the additive inverse of negative A, or sorry, the additive inverse, negative A of A, and verify that A plus negative A does equal to 0 matrix. So what we're going to do here, the additive inverse of A. So that will be negative A. Well, the opposite of 2 is negative 2. The opposite of 5 is negative 5. The opposite of 1 is negative 1. The opposite of 4 is negative 4. So there's your additive inverse. To prove that A plus negative A equals 0, that will be 2, 5, 1, 4. plus my additive inverse, now you should be able to see that this will actually give us 0, 0, 0, 0 when we add it. And this will also equal matrix 0, and my order will be 2 by 2. Now for number 3, we need to determine 3a minus 2b. So let's copy this a little bit. 2, 5, let's see. So 3 times 2154 minus 2 times b, which is negative 1, 2, 2, 5. So pretty much doing the same thing we did in example 2. So simplifying this was 6, 15, 3, 12 minus a negative 2, 4, 4, 10. Simplifying this further, and I do realize you don't have room for this on your paper, I apologize. We'll have 8, 11, 15 minus 4 is 11, 3 minus 4 is negative 1, and 12 minus 10 would be 2. So here's your answer to number 3. In the next set of videos, we're going to talk about matrix multiplication.